Welcome back, everybody. We're diving into something I've always found a bit mysterious, honestly. Hashing.
Oh, yeah, it sounds kind of complicated, right? Lots of jargon.
Definitely. It gets thrown around a lot. Like whenever Bitcoin or blockchain comes up, there's always talk about hashing. But what is it really? And why is it so important?
Good questions. I think a lot of people feel that way.
Well, luckily, we've got this article from Finance Academy called What is Hashing?
Yeah, we'll use that as our guide today.
Perfect. So let's try to demystify this whole hashing thing. What's the big picture here?
Well, imagine this. You can take any kind of digital info, anything, a photo, a contract, a whole movie even, anything really,
Okay, I'm picturing it.
and you can boil it all down into a unique code,
Like a super short summary?
more like a digital fingerprint.
Ooh, that's a good way to put it.
That's basically what hashing does.
So it's not just like assigning random numbers to files.
Oh, no, it's not random at all. There's a method to the whole thing.
There's got to be.
There's a specific mathematical formula called a hash function, and that's the key.
Okay, so there's a system.
A system, yeah. And the cool part, doesn't matter how big or small the input is, the output, that's the hash, is always the same size.
Wait, really? So like a text message and a huge database, they'd have the same size hash?
Yep, that's the magic of these hash functions.
My mind is a little blown right now.
For example, SH256, that's one of the most popular algorithms.
I've heard of that.
It always makes a 256-bit hash,
Okay.
which is 64 characters. But here's the thing. Every single input, even a tiny change, like even one letter,
Oh, wow.
makes a totally different hash.
So it's super sensitive.
Super sensitive, yeah.
I can already see why this is like huge for security then.
Oh, absolutely.
If someone messes with a file even a little bit, the hash would change, right? And then you'd know something was up.
Exactly. Like a tamper-proof seal. You break the seal, something's wrong.
Perfect analogy. That makes it way easier to understand.
Glad to hear it.
So hashing is like protecting our digital world in all sorts of ways.
All sorts of ways, yeah.
But okay, gotta ask, how easy is it to reverse this whole thing? Like, if you have the hash, can you figure out the original data?
That's where things get really tricky. That's the one-way function idea. They're designed to be, like, impossibly hard to reverse.
Like unscrambling an egg?
Exactly. You can scramble it easy, but getting back to a perfect yolk and white,
Not happening.
pretty much impossible.
Okay, scrambled eggs are stain scrambled. But what makes these hash functions so hard to crack?
Well, for security, we use special ones. Cryptographic hash functions. They're seriously mathematically intense.
So it's not just about making a unique code, it's got to be unbreakable.
You got it. And there are three big things that make them secure. Number one, collision resistance.
Collision resistance, what's that all about?
So there's infinite data you could hash, right? But because the output size is fixed, there's a finite number of possible hashes.
Okay.
In theory, two different inputs could end up with the same hash.
Oh, like two keys opening the same lock.
Yeah, and that's a problem. That's why collision resistance is so important.
Makes sense.
It means finding two different things that make the same hash is practically impossible.
So in the real world, can we just assume two files always have different hashes?
Well, a truly collision-free function doesn't really exist.
Oh.
But some are so strong, they're basically collision resistant, like SHA-256.
Okay, so that's one piece of the security puzzle.
One piece, yep.
You said there were three, right? What else makes them so secure? Okay, so collision resistance, check, that's one. What about the other two things that make these cryptographic hash functions so secure?
All right, so imagine this. You only have the hash, the fingerprint, not the actual data. Could you, work backward and figure out what the original data was?
That's a good question. I guess it'd be like trying to put together a shredded document just from the tiny pieces.
Exactly, and that's where privilege resistance comes in.
Okay, so it's basically impossible.
Pretty much. With a strong cryptographic hash function, you can't get the original input just by knowing the hash.
Gotcha. All right, so what's number three? What's the last piece of the security puzzle here?
This one's called second-preimage resistance. Let's say you have some data, right? And you know it's hash. Could you create a totally different piece of data that makes the exact same hash?
So it'd be like finding a different key that opens the same lock, even though you don't have the original key.
Yeah, that's a good way to put it. Second-preimage resistance makes it super hard to find a different input that gives you the same hash as a node input.
Wow, so these cryptographic hash functions are basically like Fort Knox for our data. Seriously impressive. But we've been talking a lot about the theory here. Where does all this hashing actually happen in the real world, like in our everyday lives?
Well, one of the most common uses is ensuring data integrity. Think about when you download a software update, for example.
Oh, yeah?
How do you know that file you downloaded is the real deal, that it hasn't been messed with?
I guess I just assume it's safe, but now that you mention it, that's a lot of trust.
Right, that's where hashing comes in. The developer can give you a hash along with the file. Then you can use a tool to generate the hash of the file you downloaded and compare them. If they match, you're good to go.
So it's like a digital fingerprint check. The fingerprints match, you know everything is legit.
Exactly.
Pretty smart. So what other everyday things use hashing to keep things secure?
Well, think about all the online accounts you have: email, social media, second websites, all that stuff. You don't think those companies are storing your passwords in plain text, do you?
I really hope not. That'd be a disaster waiting to happen.
Exactly. That's why responsible companies use hashing to protect those passwords. They don't store your actual password, just a hash of it.
So even if a hacker got into their system, they wouldn't actually see any passwords, just a bunch of random-looking hashes.
Exactly. It's a huge layer of protection. Even if there's a breach, your actual password is much safer because those hashes are so difficult to reverse.
That makes me feel a lot better knowing that. It's incredible to think that this whole hashing thing is going on behind the scenes, keeping our information safe all the time. But what about blockchain? We got to talk about blockchain.
Oh, yeah, blockchain. That's where hashing gets really interesting. Remember how we talked about the blocks in a blockchain being linked together?
Yeah, like a chain of digital blocks, each one with a bunch of transactions.
Well, guess what? Hashing is what creates that link. Each block's hash includes information from the previous block, so it makes this like tamper-proof chronological chain.
Oh, I see. So if someone tried to change a transaction in an older block, it would change that block's hash, and then the next one, and the next, and so on. The whole blockchain would basically fall apart.
You got it. It's like a domino effect. It makes it practically impossible to tamper with the blockchain without everyone knowing. That's what makes it so secure and trustworthy.
That's pretty mind-blowing. It's not just securing data. It's securing entire systems. But hold on, we got to talk about Bitcoin mining, too. That's a whole other thing. Where does hashing fit into that?
Ah, yes. Bitcoin mining. It's often described as this super mysterious process where powerful computers solve complex math problems to create new Bitcoin. And you know what? That's not too far off.
Wait, so it's not just some made-up thing. Those mining farms are actually doing something important, but, like, what exactly are they doing, and how is hashing involved?
Think of it like a giant digital lottery where miners are competing to solve a cryptographic puzzle. Whoever solves it first gets to add a new block of transactions to the Bitcoin blockchain, and they get rewarded with brand new Bitcoin.
So it's a digital gold rush. Everyone's racing to find the next Bitcoin nugget. But how do they actually mine these Bitcoins? What's the process?
That's where hashing becomes the star of the show. Remember how the output of a hash function is always the same length, no matter what you put in?
Yeah, it still blows my mind that a single word in a whole encyclopedia could have the same size hash.
Well, in Bitcoin mining, the puzzle is all about finding an input that, when hashed, gives you a specific output, one that starts with a certain number of zeros.
So they're basically trying to find a needle in a haystack, looking for this one specific hash.
Exactly. And to make it even harder, the Bitcoin network adjusts how difficult the puzzle is based on how much computing power is being used for mining. So the more miners there are, the harder it gets.
Wait, so wouldn't it be easier to find those special hashes if more people were looking for them?
It seems that way, right? But this system is super important for keeping the Bitcoin network secure and stable. If it was too easy, someone could take control by making blocks way faster than everyone else.
Ah, I see. So it's like a balancing act. Making it harder as more miners join keeps things fair and prevents anyone from getting too powerful.
Exactly. It's a brilliant system that keeps the Bitcoin blockchain decentralized and trustworthy. Plus, as miners put more computing power into the network, they actually make it more secure overall.
Makes sense. So how do they actually go about finding those special hashes with all the zeros at the beginning? Do they just keep trying random stuff until they get lucky?
It's more sophisticated than just random guessing. They take all the pending Bitcoin transactions, put them in a block, and then they start playing around with a little piece of data in the block called a nonce.
A nonce, what is that?
It stands for number only used once. It's basically a random number that they add to the block data before they hash it. They keep changing this nonce and hashing the block over and over again, millions of times per second, until they get a hash that matches the rules, meaning it starts with the right number of zeros.
So they're like trying on different hats on the block data, hashing it each time until they find one that fits.
Yeah, that's a great way to think about it. And when they find a valid hash, they shout it out to the network. The other miners check it out, and if everything looks good, the new block gets added to the blockchain. And the miner who found it gets their Bitcoin reward.
Wow. This whole process is totally dependent on hashing. It's like the glue that holds everything together. Amazing. But let's zoom out for a second. We've talked about hashing for data security, passwords, and even blockchain. But what does it all really mean for, regular people like us?
That's a great point. I think it's important to remember that hashing is working behind the scenes all the time, even if we don't see it. It keeps our online shopping safe, makes sure our downloaded files aren't messed with, and protect our passwords. Hashing is basically keeping the digital world running smoothly.
Like our silent guardian, a digital shield protecting us from all the craziness of the internet.
Exactly. And as things get even more digital, hashing is going to become even more important. But here's something to consider. What happens when quantum computers become more common? With all their power, could they actually break these codes we're relying on?
Ooh, that's a scary thought. All this security, and it could be vulnerable to these superpowered quantum computers. It is kind of scary to think about, right? Like, is all this security we've been talking about, is it all going to be useless when these quantum computers really take off?
It's a valid concern, definitely. It's something that cryptographers are very aware of and working hard on, because quantum computers, they're not just faster.
Right, it's not just about speed.
They operate on totally different principles. Quantum mechanics, the whole thing is mind-boggling, honestly.
Sounds like it.
And that means they could potentially crack a lot of the encryption we use today, including some hashing algorithms.
Oh, wow. So it's like a race then. As quantum computers get better, we got to come up with even stronger cryptography to stay ahead of them.
Exactly. It's a constant back and forth. But the good news is the cryptography folks are on top of this. They're researching and developing quantum-resistant algorithms. Like, imagine building a new Fort Knox, but even stronger to protect our data from these quantum computers.
Okay, so at least people are working on it. That's a relief. So there's this potential threat, but there are also people working hard to stop it.
Absolutely. And this research is moving fast. They're trying to create algorithms that are strong against, both regular and quantum computers. That way, our data stays safe no matter what technology comes along.
It's pretty amazing to think about. The whole future of security might depend on this battle between quantum computers and these super smart cryptographers.
It's a really exciting time to be in the field. We're essentially building the foundation for a safe and secure digital future, even with these crazy new technologies coming out all the time.
It's pretty wild. Okay, so we've learned about hashing, how it keeps things secure, and even how quantum computers might challenge that in the future. It's incredible how this one concept, hashing, is so fundamental to our digital world.
It really is. It shows how creative humans can be, coming up with these systems that are both complex and incredibly secure.
Well, that brings us to the end of our deep dive into the world of hashing. I hope you found this as eye-opening as we did. Hashing isn't just some techie thing. It's the foundation of our digital lives. It keeps our data safe and makes all these amazing technologies possible.
It's been a pleasure exploring this with you. And remember, the world of hashing is huge. It's always changing, so there's always more to learn.
Always more to explore. Who knows? Maybe one of our listeners will be the one to develop the next generation of unbreakable hashing, ready for anything those quantum computers throw at us. Thanks for joining us on this deep dive, everyone.